As we begin our study of thermodynamics, it would help to recall the first law of thermodynamics from early lessons on thermochemistry. Essentially, the first law of thermodynamics says that energy is conserved in a chemical process. In other words, when burning gasoline, some energy goes to driving the car, but some energy is lost as heat. You can never increase the total amount of energy. The total energy in a process is constant. In addition to the first law of thermodynamics, there's also a second law of thermodynamics, which dictates that essentially every time there is an energy transaction, a little bit of energy is lost. Scientists sometimes call this a heat tax. As a result, the most efficient use of energy involves the smallest number of energy transactions. So for example, it's much more energy efficient to heat a home with natural gas, where the natural gas in the home is used directly to heat the house, instead of using electricity to heat a house, because the electricity is produced somewhere else, transferred through miles of wires, and then comes to the house, where it's then used in an electric heater or an electric furnace to heat a house. There's many more steps and energy exchanges in heating with electricity, and so it's a less efficient process. One of the main goals of thermodynamics is to predict the spontaneity of chemical processes. Will a metal spontaneously oxidize in the presence of oxygen? Will nitrogen gas and oxygen gas spontaneously react to form N2O gas? Spontaneous processes are those that occur without ongoing outside intervention. For example, a ball will spontaneously roll down a hill, but it requires ongoing work to move the ball up the hill. As we get into thermodynamics, it would be good to compare this to what we learned recently about kinetics. In discussions of kinetics, we focused on the middle part of this reaction diagram, which dictates the speed of a chemical reaction based on the energy barrier, or the activation energy. When learning about thermodynamics, we will focus on the difference in energy between the reactants and the products, known as enthalpy, and we'll also introduce another concept, also related to energy, called entropy. After watching this video, you should be able to recall the first law of thermodynamics. You should also be able to use words and examples to describe a spontaneous process. Finally, you should be able to explain the difference between kinetics and thermodynamics in terms of a reaction diagram.